Hi, everybody. Miss Langell here. I miss you all. I'm sorry I haven't been able to post anything for a while. I've been working on a lot of math department scheduling stuff for next year, and that took me like 3 days to finish. And so I haven't been able to create new content for you. But I look forward to reading what you said on the survey, and I will post something tomorrow to like give us a chance to look a little more at quadratics. So this last week, I gave you two different activities to do. One that was, will it hit the hoop, about this guy like doing some basketball shots. I hope you enjoyed that. And then another one about building a bigger field. So I'm gonna take a look at a couple of both of those and just make sure that you know at least some of the things that make them quadratics. My goal for you is you're not gonna learn like every single thing that you would ever need to know about quadratics. Your teacher in Algebra 2 years from now is going to need to like reteach you some of that stuff, but I want to give you some really strong context so that anytime you see stuff about quadratics, you already have like a sense for how it works, and it's really easy for you to learn anything that you're missing. I will do my best to make sure that you have some of the basics to work off of. So these quadratics, these are both quadratics here, this like parabola shape that the ball goes through. And that's one of the like key like classic things that has this shape, is anything that has to do with gravity, where like something's going up but gravity's fighting against it and eventually it'll start coming back down. It usually makes a parabola shape, which is what goes with a quadratic. So another thing that often has to do with parabolas is anything that has to do with area. So like these things where you were building different size fields, where you had like a skinnier or wider field and you were doing length times width, that actually often turns into this parabola quadratic shape. Like if you take a look at what students said, they were like, oh, it made an arch, it was still scattered points, it goes up and then down. If you connect them, it would make a parabola. I noticed they're all scattered, they're going up and down. So that going up and down shape, that is a quadratic shape. And yeah, there were some scattered points out here. I think those were errors. I know they were errors. In fact, one student pointed out that there were only a few that weren't following along the usual pattern. That was really great. Like all of these here, they're following the pattern exactly, so you know they're correct. But if you're a student who looked at their stuff and then said, hang on a minute, these two are following the pattern, this one up here isn't, maybe I should go check the row that actually goes with that and say, hang on, the one that said the length was 13, maybe I should go back and actually check that one and see if I made a little mistake. I think this person thought that the length and the width were both 13. It should have been 13 and 12. So yeah, this thing doesn't want to work. Okay. So yeah, like, and you can see in this one too, like this one in the middle was a mistake. These two both work, they fit the pattern. The student should go back and check their one that was about, I think, 12 and see like, did I get the width wrong or the area wrong on that one? So all of these fields had the X's were the lengths of the fields, and then the Y was the area. So the length was this column here, and the area was what you all figured out over here. So this student had 3 different lengths. One that was only 3, like this isn't the same student. Yeah, these don't quite match. But anyway, 3 and the area was 66, and then 12 and 156, and then 17 and 136. So there's just this other one here. And I don't know if you noticed that if you had let me show myself again. So if you have a width of 3, the whole area of the shape was 66. It was like, I don't know, like this with my bandana, because I have no string apparently in my grandpa's house. Like 3 here, but the width that goes with that is 22. So what happens if your length is 22? Still the same rectangle, still gonna have the same shape, like area inside. The width will be 3 instead, and the length times width will still be 66. So each one of these had kind of like a this way or this way version of the rectangle that sort of made it mirror on both sides, which is kind of interesting. So far we know Things that have gravity tend to like go up and come down in a parabola shape, which is a quadratic, and things that are length times width tend to be and make a quadratic shape too, where like length and width sort of go together. And one of the most interesting questions to ask was, where will it have, okay, yeah, this is where people were talking about how you could have the same length, the same area depending for the rectangle, because depending on where the length, which one was the length and which one was the width. Okay, so anyway, one of the interesting questions to ask was, where would the area be the biggest? Like, what's the dimensions that gives you the biggest one? And I think intuitively you already kind of know that a long skinny rectangle doesn't actually have very much area inside, but if you make it more square, make the sides more even, then you can fit a lot more space inside. So that's definitely the case here. And most people, I think, actually picked, I don't know what happened here, FYI, that why it's like spread out the dots that we had clearly marked. If you did the equation right, it should have looked like this. So anyway, back to highest point, or the like biggest area. So a lot of people were looking for where's the highest point on the graph. A lot of people picked this one up here, which actually doesn't work because that was a mistake one. If you're looking at where it actually fits the graph, it'll be someplace right between these two here. You see where my cursor is? Like these two are both 12 by 13. They're almost perfectly square. If you like split it all into being perfectly even along the sides, like it would be 12.5 for each, that would make a perfect square with a perimeter of 50. And that's where you would find the very highest area. Like I think you can go a little bit higher up in here, and then before it starts having to come back down because the other side's getting smaller or longer. So that was some things to notice or know about length by width and how it makes this quadratic thing. And then I wanted to show you a couple of things about the quadratics and how that like highest point was also pretty important for the basketball throws too. So if we take a look, like this one obviously is nowhere near what the basketball is doing. It's not going down and then coming back up, it's going up and then coming back down. This is a like regular shaped parabola, and these are what would be considered upside down, but it's the one that made sense for what we were doing. And even if you like matched up part of it, it was pretty important to match like the whole thing to get the right trajectory of it. And this is when I want you to take a close look at which one of these is a better fit to the shot. This one's like following it along pretty well the whole time, so is this one. What's really important to get right is where that very top like point is, where the ball starts coming back down. That was like the most key one. If you got that one, then you got the whole other half as well, and you could figure out pretty much exactly where that ball was going to land. So one other interesting thing to notice about this is that highest point is called the vertex, and that highest point is one of three ways that people use to make these equations. We'll go a little bit into some more detail about that. I'll try and have some like things for you to try out to see how that works, like how that vertex actually fits into the pattern. So a lot of people noticed, they looked at where that point was on the graph and they were like, hang on a minute, I hope you saw where it came from. That's where this ball is arcing back down, where it's the highest it ever gets and it comes back down. I saw some really great clear things, and some people being really specific about what those numbers meant. Like it's halfway between the guy and the net, where the ball, I don't know if it stops there, but like stops going up and starts coming back down. It was really excellent. So the only thing I want to wrap up with is to show you, no, not that. Just keep on doing this. The only other thing I wanted to show you was, come on, how these equations look on the graph. So the basic thing that makes a quadratic is an x squared like this. And you might be thinking, we saw this before, this was an exponential. Let me give you an example where the x and the 2 are switched. Actually, I'm going to do it down here. Totally different shape. Do you notice how the black line goes down and then comes back up. It's got this curve, I shouldn't call it a line, this curve goes down and then comes back up. And here's that turning point, that vertex right here at 0, 0. It's called the vertex or a turning point. Now, if you take a look at this one, it never goes down and comes back out. It starts flat and then it starts shooting up. The thing that's changing here is the exponent. That's what our x is. Here, the exponent is always a squared. It's always something that's kind of square, which is gravity has to do with squaring things, and so does like having the area of a field is about like squares and what squares will fit inside, and that's one of the reasons both of these are quadratics. So here, an exponential changes the exponent. In a quadratic, it's always squared and you just change what you're squaring. So, and that makes it have this interesting shape that where it like goes down and then comes back up, or maybe it goes up and then it comes back down with a vertex or a turning point. Exponentials are something very different. Instead of having to do with like area or gravity, they tend to be things where like the more you have of something, you get even more of it, where it's like increasing by a constant percentage. Like for instance, however many people are infected by COVID-19, a certain percentage of those tends to go and infect some more people. So the more you have the infected, the more they're infecting other people, and then they're infecting more people and they're infecting more people, and suddenly it shoots up when it looked like there was nothing, and then there's like tons overnight as it sort of snowballs and gets huge. So I'm going to click that off because it's not an example of a parabola, and I will show you a couple of other ones. Here's the vertex for this one. And this is our example from just the equation from the hoop, the like basketball one, and then this one's super high. Should I click these off? I think I will. Here's that super high one here for the length times the width of the build a bigger field. So let me make this go up to just 26 because that's all we had. So you could kind of see where our very highest spot was. It was 12.5 for the length. And if you figure out what's left from the 25 or the like 50 all the way around, that means the other side will also be 25. So it's a perfect square. And 20.5 times 12.5 times 12.5, length times width gives us our perfect area. All right, there's more I could say. There's lots of interesting things to know, but the things for you to take away from this were looking at some of the interesting things that other people did, and to know two classic key scenarios that almost always end up with this quadratic shape. Things that have to do with length times width and area, and things that have to do with gravity, because both of those things usually involve squares or squaring stuff. And just to know the difference between squaring things where you're always multiplying it times itself or raising it to the second power, and how that's super different than an exponential, where you're changing the exponent instead of just squaring. Okay, have a great evening. I look forward to reading what you all said, and I will try and post something else soon for you tomorrow. Bye.